Hello, welcome to your Unit 10 Lesson 5 notes on solving compound inequalities. By the end of the day, you will be able to solve compound inequalities. Great, right? Well, here's some fun language facts. We'll start at our fun language facts with something not fun at all. I've had Justin Bieber inexplicably stuck in my head, and I don't know how it got there. So if you can please send help, that would be awesome. Let's put some Spanish words on here. Compound in English. This is something as compuesto, which is like jamming together. Con and puesto. Con, y'all know, means with. Puesto means put. That's what compound means. It means you put something with something else. It's put together. Compound is put together, just like a component. Same kind of deal. Anyway, so a compound inequality is we have two inequalities that you put with each other. So we call it two inequalities form a compound inequality. Okay, we can join them together with either and or. But when you do that, you need to make sure that the inequality symbols face the same direction. That is, you can't have this nonsense right here. We have z is less than 6 and z is greater than 2. So you need to switch them around. And when you switch them around, you also need to flip that inequality symbol. So we can rewrite this as 2 is less than or equal to z, like that. And now we can join them together. And how we do that is we take their overlap. So we've got z is less than or equal to 6, and 2 is less than or equal to z. See how they have that z in common? Our new inequality then is 2 is less than or equal to z is less than or equal to 6. So and, guys, is where you find their overlap. Like that. This would be, we got to rearrange, got to flip them around. -4 less than or equal to y, and y less than 10. Whenever you've got and means overlap, so you literally overlap them to get your new inequality is -4 is less than or equal to y is less than 10. Cool. So whenever you have and means overlap. Yeah. Or, however, is either this area or that area or the space in between two. If they overlap, it would include their overlap as well. Okay. And is used to describe the intersection. It's where they intersect. It's what they both have in common. It's going to say what both inequalities are true. So we looked at our example up here of y is less than 10 and y is greater than -4. So greater than or equal to -4. So that's going to be this area between them, that overlap right there. Or, on the other hand, we call the union of two sets. It's what either one of them has. So usually there's not overlap, actually. You'll have like one number here, one number here. I didn't give you examples, but they'll split like this. So or is splitting and is overlapping. So here we go. Let's graph each compound inequality. How you graph a compound inequality is you pretend like one side doesn't exist for a while, and you just graph that side. So w is greater than 25. To graph that, we'll put an open circle at 25 and go all the numbers greater than w. And then we'll pretend the other side doesn't exist for a while. Now we've got W is less than 50. So we'll make a number line over here. We'll put a 50 on it. But W is less than or equal to 50. So we're going to put a solid circle on 50. And we're going to go that way. Oh, and look, we've got this amazing overlap space. So we'll shade in the overlap area. Cool, cool. I'm going to just skip these because you don't need more examples. We'll do examples together in class. Now let's look at an OR one. Again, you're going to split it up and just graph this side of it, right? If we've got y is greater than 5, then that's an open circle on 5, going big. Oh, and then y is less than 2. We need to move this to the other side because 5 is over here. You know, good enough. Whatever. Or y is less than 2. So that's going to be a less than or equal to is a closed circle. If y is less than 2, we're going this way. So that's a nice little split. Isn't that cool? So there's our graph. Right? Like that. Cool? So and will always overlap. And or will always split. Sweet. Okay, so now we got one more. We need to figure out the solution first. Now, how do we graph how do we find the solution of a compound inequality? Well, we need to split it up. We need to treat each side like its own little inequality. Yeah. So when we're trying to get x all by itself right here, we're going to undo this plus 1. We'll undo this plus 1 by subtracting 1, but we need to subtract 1 on every single little section. So that goes 9 minus 1, which is 8. It's greater than or equal to x plus 1 minus 1 is x, is greater than 5 minus 1, which is 4. Apparently I was overzealous with my dashed lines. Aha, there we go. There's our solution right here. Now we need to graph it. The numbers we're playing with here are 4 and 8. Now we've got that x is less than 8. 8 is greater than or equal to x. So that's a solid going that way. And then we've also got x is greater than 4. So that's open going that way. And honestly, guys, if you just kind of do that, that's okay. Actually, I take that back. Let's just shade like this. And they're all done. Yay. Remember, and means overlap. This side, however, we've got an or. So for or, we're going to split it up like a seal. Or. And we'll solve this side first. To undo our 3 times x, we're going to divide by 3. And that gives us x is greater than 6. Or, here to undo this minus 2, we need to add 2 to both sides, giving us x is less than 3. Again, overzealous with the dashed lines apparently. And now we need to put this all on a number line. The numbers we're dealing with are 3 and 6. So either x is greater than 6, gives us an open circle at 6 going greater, or x is less than 3, gives us another open circle at 3 going less than. Because remember, or splits and overlaps. That's it, and have a fantastic time on your homework.